Welcome to session 2, Code Conversion Best Practices. Before we get started with our presentation, I do want to share a few reminders. As our speakers present, please remember to stay muted to minimize distractions. If you have a question during the presentation, please submit it using our Zoom chat. At the end of the session, the questions will be answered by our session speaker. So just a reminder that this session will use a Databricks notebook. Laura dropped that link prior to our break, but she'll be doing it again to make sure that you can access it during the demo. Derek has also linked it in the presentation, so after the fact, we'll be sharing out the decks, and that will be on our Confluence space and then within the deck as well, so you have access to it multiple ways. Our session today is presented by Derek Cruikshank, and he will be giving you some more information about his background as well as his presentation. So with that, Derek, I will pass it over to you.
Thank you, Julia. Yeah, so Derek Cruikshank, I work on QDAS. My background is in statistics, data analytics, data science, much probably like a lot of everybody on the call is. I've been programming within SAS since 2009. Picked up SQL along the way. As far as Python goes, I've been coding in that for like 4 or 5 years. I kind of refer to myself as a Google Python coder at this point. But I'm kind of going to show you a little bit of how I get things done and how it works for me to kind of give you all some ideas of, additional tools externally that you can utilize to also help you get, SAS code transitioned into some kind of Python or R type of language, as well as SQL. So with that, what I'm going to be covering in the next slide is what I want to talk about is like the differences between Python and R, right? And which one's going to be right for you. And of course, that is an incredibly loaded question because really it's going to depend on your background as well as what it is that you're doing. I'm going to talk a bit about some of the resources and trainings and tools that we're going to be providing the CCSQ community during the SAS transition, moving forward into this summer and throughout the fall, going all the way into the winter and everything. I'm also going to talk about something that's coming, which is going to be Databricks Assistant. It's going to be implemented into production here very soon, as well as I want to talk about ChatGPT. I'm sure everyone is well aware of ChatGPT. If you're not, you are going to become very well aware of what ChatGPT is and how best you can utilize it and what it can do for you. Of course, there are certain things we need to make sure we do when utilizing ChatGPT, but I'll touch on some of those things in my demo presentation and how I've put together some stuff with the help of my very dear friend ChatGPT. And then briefly talk a little bit about some additional tools that we are also kind of working with some other contractors on some pilots that could help with actual code conversion between SAS and Python or SAS and R or something of that sort. So with that, I can go ahead and share my screen and just kind of jump in to the Python and R discussion. Can you see my screen, Julia?
Yep.
Right. Yeah, and so again, as we mentioned, all of these notebooks that we're going to be presenting are available to all users within the Databricks workspace. One thing to note is that I'm going to touch on it a little bit later, but right now a lot of this stuff is in our CDR PDA QDAS organization folder. We're going to be coming up with a much more community specific folder and process when it comes to where these notebook demos are located, as well as what this CCSQ community code repository is going to kind of look like, at least in the short term, and then overall in the long term as well. And so with that, I'm going to just kind of dive right in. Obviously, what you're looking at here is a Databricks notebook. I've currently got it attached to our CDR PDA QDAS compute cluster. What I want to highlight here a little bit is the ability to use Mark. This is something it's not available in SAS. You can comment all you want in SAS, but the ability to utilize markdowns and have this table of contents that gets created within the markdowns to be able to just jump specific sections within this entire notebook is really, really useful. So definitely something that I would recommend you all kind of, consider looking into, and stuff that will include material around it. When you go to create a new command window, you can identify whether it's code or text. You can switch code command windows to be marked on text, but basically it's this %MD that allows you to kind of utilize different titles and subtitles and bullet points and lines, and you can even, as you'll see, create tables. There's a lot of stuff in there with Markdown that I feel like could be very useful, that we will make sure we explore and have lots of available information on to the community on how you can best utilize it. But with that, I kind of want to go into, Python and R. Removing SQL and Stata out of the picture right now, Python and R are going to be probably two of the most common languages outside of SQL that a lot of users will end up utilizing within Databricks. So a lot of people have talked about, what should I use? Which one's easier to learn, Python or R? Well, it's not as simple as just, Python is easier or R is easier. It's obviously dependent on your background, dependent on your experience, and dependent on what specifically it is you want to do. Because what you can do with Python is very there's a lot more variety, and it has its strengths over what R can do. And same with R. What R can do has its strengths over what Python can do. So a lot of it's going to depend on what is it that you're doing within Databricks to kind of help you determine, is Python the right thing? Is R the right thing? So we can be doing things as efficient as possible. So as far as Python goes, it's probably one of the most utilized broad-ranging applications across, developers and the industry of programming languages. It's an object-oriented language, and it's really heavily utilized currently within the data science industry. It does a lot with its ability to understand its readable and clear syntax, meaning it forces indentations, it forces you to code the syntax in a certain way that can be very easily interpreted, and when you're looking at it, you can really kind of understand exactly how it works and how it flows. So a lot of people have said Python can be a little bit easier to learn than R, simply just because of that readable syntax, and it's a little bit easier to pick up and learn than R is, because R is very much more specialized in what it does. R is a lot more of a niche type of programming language when it comes to statistical computing, statistical analysis, data analytics, things of that nature. But with Python, we've talked a lot about, there's lots of packages that are out there. It does allow you to have a lot of different data structures that you can utilize, specifically lists, dictionaries, and sets, as well as obviously data frames that we've talked about, whether it's a pandas data frame or it's a Spark data frame, which the presentations later on around Python and R will get a little bit more into the differences in those types of data frames. But it allows you to process a very, very large amount of data very quickly in a very distributed nature, as well as the ability to execute things in parallel while it's also distributing. So you can do a lot of really interesting things utilizing lots and lots of data, and you can do it very, very quickly. Um, so it does allow for data visualization, data manipulation. There's lots of visualization packages, as well as there's specific packages around machine learning and deep learning. I'm sure some people who are familiar with machine learning and Python are well aware of what scikit-learn is, as well as PyTorch and TensorFlow when it comes to more neural networking and deep learning languages. Um, it does also allow you to do a lot of file manipulation, system administration type stuff. So when it comes to automating repetitive tasks and creating scripts, Python is definitely going to be a very powerful language to utilize within for loops, within being able to create lists, nested lists within dictionaries. There's a lot of stuff that's out there. And again, what I'll talk about a little bit later is its unique ability to really work with Spark, which is where you're going to see a lot of super fast processing due to the distributive nature of how Spark works. The last thing I want to touch on with Python is its community of users and developers. It is a lot larger than the R community is, simply because Python has a much larger variety of different things you can utilize it for. If you want to make API calls, if you want to create your own web pages, obviously none of this really fully makes a lot of sense within the scheme of what we're talking about in CCSQ with data and analytics, but web scraping and API calls and all this stuff can be utilized very easily, very quickly. It's all supported naturally within its libraries. And again, like I said, it's got very large and a very diverse community of users and developers that are creating these packages for everyone else to utilize, as well as creating them, wrapping them within the Spark engine. R, as mentioned, R can do a lot of what Python does. Python can do a lot of what R does. What R is very good at is statistical modeling and data visualizations. Again, to say that that's not available in Python is lying. Statistical modeling is available in Python. Data visualizations are available in Python. With R, it can maybe be a little bit friendlier. You can also make things, it's a little bit easier to make things aesthetically pleasing within data visualizations. Python can be a little bit more tedious and programmatic to make things look nice compared to what maybe comes out of the box with R. Obviously, R was developed by statistician professors and biostatistician professors, so it makes sense that its niche is with statistical modeling, statistical analytics. It's very heavily utilized within academic research, within the academia industry. So yeah, I mean, depending again on what you're trying to do, R can be very strong at certain things, and then Python can be very strong at other things. As far as ease of learning, as I mentioned, a lot of beginners, coding programmers, they find Python to be a little bit easier to just to learn. It's the syntax, the versatility, the amount of resources that are available within the community. It makes things a little bit easier. It makes things can be a little bit more intuitive as you're programming and learning how to utilize things and do things. So there's a lot of really good, useful tutorials and documentation and online resources and things out there to really help people learn, from the very introduction of Python to how do you utilize machine learning? How do you build neural network deep learning models? How do you do simple data cleaning, data analytics, data visualizations? There's a lot of stuff out there that's available to basically anybody looking to learn it. R can be a little easier to learn if your background is in more statistics. I did not learn R in undergrad or grad school. We did a lot more SPSS, did SAS, but what's being done now within universities, R is a really big thing on the statistics side. So, there's a lot of very statistical focused and specialized packages within R that allows you to do a lot of things. um, you'll see there are some limitations as we move down around some of those packages, but it is very good at being able to have, good visualizations and a little bit easier way to make them out of the box look a little bit nicer, a little bit cleaner than what Python might be able to do. So one of the biggest things is going to be scaling. What's the scalability like between Python and R? And when I say scalability, I mean, what is its ability to process really, really large amounts of data? Because obviously you're working with claims data, you're working with assessment data. There's lots and lots of data that's available, and you want to be able to efficiently code what you're doing and make it run as fast as possible. So being able to utilize the Spark integration, which again just basically means we're distributing the processing, we're distributing the data. So it's not all just being ran on one single server, it's being ran across, up to 30 some servers, each server being able to scale up to a certain amount of memory and processing capabilities. So you can imagine utilizing Spark when you're processing really large amounts of data is going to be very imperative, very important in what you're utilizing and understanding the different packages that come with that Spark compatibility is going to be key. So as talked about here, Python definitely does have an advantage over R when it comes to processing really large amounts of data, to the fact that it can scale with a Spark very, very easily. It's very efficient in the memory management, and it can really offer a lot of different ways to be able to parallel process things, utilizing specific parallel packages that come with Python. R can have its issues when it comes to memory management. When you're working with really, really large amounts of data, the amount of memory and how R in the back end, the R kernel utilizes its memory and manages it is not as efficient as Python does. So it can obviously can lead to lots of errors when you're needing to use more memory than what you have. A lot of also what R has with some of its more statistical packages, as well as just the R support and community in general, it has not adopted Spark as much as Python has. So a lot of what you might be running could be ran in just simply base R language, which is going to run on the single driver node, and it's not going to utilize Spark in its capability to distribute that processing and distribute the data. So it means you're really limiting yourself to a single node, to a certain static amount of RAM that you're going to be utilizing or making available to be able to process. There is Spark R, which is obviously the R API for Spark, and it does allow a lot of similar functionality that PySpark allows. So again, when you're working with large amounts of data, utilizing Spark R rather than base R is always going to be best practices. However, again, because that user community of R is a little bit smaller and less diverse, and it hasn't adopted Spark as quickly and as much as Python has, the Spark R integration, it's not quite as mature, and so there can be some things that you could run into issues with as far as exactly what it's doing. But again, if you're working with not super large amounts of data, you can easily utilize R and its packages around data analytics, statistical modeling, and data visualization. Again, when it comes to that overall syntax, R is a little less intuitive. It is maybe a little bit of a steeper learning curve to learn the type of syntax than maybe what Python is. However, it's not to say that it's incredibly difficult, because it can be learned, and there are a lot of useful resources out there online within the R user community that are available to help users learn how to utilize it. Again, in summary, what is best for you? Well, it's going to depend on exactly what you're wanting to do. If you're working with large amounts of data and you're simply processing and you're manipulating it, joining, cleaning, creating flags, all of that stuff when it comes to measure calculations or whatever it might be. Python, especially utilizing the Spark integration with Python, is going to be the preferred method. When it comes to smaller amounts of data, when it comes to more statistical models, R is going to be a lot more similar to its default output to what SAS might default in its output for statistical models. Python, again, really good with deep learning models, really good, and does offer statistical modeling. There are some things that maybe need to be done outside of packages in order to produce some of the default outputs that you might see automatically being produced with statistical models from R packages, or from what maybe you're used to with underlying procedures within SAS. But it's not to say that it cannot be created and generated and produced within Python. It might just take a little bit of extra syntax, a little bit of extra programming to produce those. And like I said, Python is definitely going to be a lot more versatile when you're utilizing databases in data and working with data frames and writing it back to databases. Python is going to be much more efficient with that utilization than what R would be with. So again, it really depends on what your background is, what your comfort level is, and again, what you are doing when it comes to if you should be using Python or R. Yeah. So with that, I will jump into some converting SAS code. So I mean, what I want to talk about briefly in general is just some tips that I've kind of found useful. I know the DVA team did a great job previously talking about what they were able to do in really migrating a lot of their stuff, and they've seen a lot of really good stuff coming out of it. And so the idea here is you really want to break down and identify common code that you and your team utilize. And that's and you want to break it apart when it comes to trying to actually transition and migrate that code into Python or R. So you're not tackling one massive program at a time. It's more you're tackling specific things within your programs that are utilized heavily across lots of things that you do within your processes. So you do a lot of data steps with arrays to create flags on diagnosis codes, which you'll see a little bit later. There's ways to tackle it, segmenting it, smaller chunks, one at a time, and then being able to bring your code in to that Python in R type of language to be able to then adapt it to the next thing. And so there's really a lot of stuff on how you can approach this efficiently when it comes, like, there's a lot of code out there. I know we've got lots and lots of SAS code. I do as well, and being able to really identify what is the code doing and segmenting that and clustering that into specific groups to then tackle each group, right? How do I do this overall thing in Python or in R? Do it for one of them, and then you can adapt it and adjust that for everything else that you're doing in that same segment, right? And so it's really moving across the different functionalities that you're doing in your SAS code and not necessarily moving across each SAS program, because that's how you can really implement and as you are starting to build, your knowledge and understanding of how to modify this and how you can, tackle frequency procedures or sorting or merging of data frames or doing all of these different specific things, having that understanding and being able to just simply take that as a starting point and adopt it and modify it into what you need to do with it is going to be incredibly useful and efficient with transitioning your code. A lot of that, like I said, it's really just building onto what you're doing, and then as you're doing it, it's just going to become faster and faster. One What I want to talk about a little bit, real briefly, is some of the resources and tools that we are going to be creating and providing to the CCSQ community. I've talked about this community code repository. What is that? What is that? What do I mean by that? What we're going to be building out and what we currently are building out and going to be implementing out into the future and continuing to build is very specific use cases around code. And it's going to be built into notebooks, just like these. So I demoed a couple of things back at fall. There's going to be some R and Python demos during this data camp. And what we're going to be able to do is pick out those pieces around sorting data frames, around removing duplicate observations, around how do I create frequency distributions? How do I replicate a means procedure? How do I transpose data frames? How do I merge data frames? All of that stuff is going to be available within a single folder that will be broken out between Python and R scripts, and it's going to be very use case specific. So you don't have to scroll through a really large notebook to try and figure out, how do I sort data frames? How do I create a new column within a data frame? It's going to be a specific notebook itself, and you can go straight to it, open it up, and you've got code that's going to show you, here's how to do it with PySpark. Here's how you can do it with Spark.pandas. Here's how you can do it with Pandas. Same with R. Here's how you do it with Spark R. Here's how you do it with Sparkly R. So that it's going to be very accessible, very easy for users to be able to look at, scroll through, figure out what is it that they need, what are they looking for, and they can just open up that notebook right then and there, and they're not having to reinvent the wheel. They've got a good foundation on exactly what it is they need to do and how they need to modify it to make it work for them. Eventually, as we're moving forward, this is going to be put into some kind of a Git repo, and we're also going to be building out this community of practice that we really want to really generate across the CCSQ community, to even allow all of you to contribute to this code repository. If you found something that you've done that is super useful, super helpful for you, I guarantee you it's going to be super useful and helpful for somebody else. So to be able to have a process that's standardized, that goes through specific reviews and coordinated efforts for users to be able to share the code that they are developing and utilizing across the CCSQ community is only going to make this transition easier for everybody involved. So as we continue building that out and coming up with that defined process and what that's going to look like, we're going to continue to communicate with all of you and really help us build out this lack of support across contracts and across the CCSQ community that we just don't really have right now. Something else we're going to be putting out there is support Slack channels. They're going to be built around specifically for Python, specifically for R, so that we can have users go and, whether it's questions or if it's, hey, I want to show people what I'm doing. This is super cool. This is really useful. I'm going to show them how I'm doing this, what I'm doing, and make it available to them. And so people can take a look at it and we can share this across the community. And again, it's only going to strengthen everybody on these contracts, everybody across CCSQ, in how we can build a community around migrating SaaS, around utilizing Databricks and Spark and Python and R and SQL to its fullest capability, to make everybody unsiloed. Everybody, what's being done one way might be being done a different way, might be being done a whole different way here. There's one good, efficient way to do it. Maybe there's a few different efficient ways to do it. So being able to share that across the community to say, hey, you're doing this. If you do it this way, it's going to speed your processing time up by 50%. That's really what we want to try and try and simulate and bring into the CCSQ community. Like I said, we are going to be within the portal posting lots and lots of answers to frequently asked questions. We're going to be creating lots of material around best practices, around knowledge base articles, even micro training videos around specific use cases within the Databricks interface, within specific use cases of how you do a certain stay process with claims using Python or using R somehow. Being able to, I mentioned office hours. We're going to be rolling out office hours slowly over the next few weeks or so, moving forward into the summer, into the fall, where we're really going to present on topics and really dive in, allow users to come and really have it be the ability to ask questions, the ability like data camp, except it's going to be much more narrow focused around specific use cases. We can develop the topics, but we also really want to encourage the user community to come up with ideas and what you guys want to see so that we can help build that out, help demonstrate how to best do it, and then build additional training materials on top of that for everyone else to be able to utilize and move forward with. So I want to touch a little bit briefly on some of, there are external resources. There's lots of stuff out there. You want to learn Python? There's lots and lots of free introductory courses into Python, into R. There's lots of free courses that are specific in how can you integrate Python with Spark? What can I do with Python or R around data analytics? Coursera, Code Academy, Data Camp. These are all pretty much free courses that you can sign up, log in, and really take introductory courses, take courses around how do I do data analytics with Python? How do I utilize PySpark? How do I utilize Spark R? How do I create data visualizations with R? All of this stuff is out there. There's even Udemy. This does cost money. And as we move forward, we're definitely going to post specific types of trainings that we think that we know are useful. Either we've taken them ourselves, we've got people who have taken them. So again, as the user community, you're going through certain things, you're learning certain things, sharing with us what you found useful, what courses you maybe took that were super helpful is only going to be more helpful to the community so that we can share that to the rest of the community and say, hey, take a look into this course. A lot of people are finding it very interesting. A lot of people are finding it very helpful, useful. Whatever we can do to work with each other, to help each other, because we're all in this together. We've all got to migrate SAS code into some other kind of a language that we maybe aren't familiar with. So the more helpful we can be with each other, the easier this transition is going to be across the community. And lastly, before I get into some specific demos, I want to talk about some external tools that are out there. Databricks Assistant. This is coming to production Databricks. Right now, I can kind of show you a little bit about it in our pre-production. It's really very similar to what ChatGPT can offer as far as it's an LLM model. That's kind of duplicative. It's an LLM, and it allows for you to ask it questions. It allows for you to figure out like what can you do for me? For me. And it simply lays it out. Here's all the different things that I can help with. Again, this is going to be available directly within Databricks notebooks for you to do it. You want to, how do I loop? Actually, I'll just say, provide me Python code that loops through a pandas data frame and pulls out values for a column. It's going to lay it out. Here you go. Here's code. Does exactly what you're asking it to do. Obviously, as you're going to find out, this is not always going to work. You've got to modify it a little bit, right? You've got to understand what is it doing? How can you modify this? How can you implement this to make it available to work for you? But obviously, I don't know maybe how to do this specifically. I can Google it, but I can also ask it. Ask Databricks Assistant. And again, what I'm going to show you specifically is working with ChatGPT. What Databricks Assistant will provide is a lot of what ChatGPT already can provide. And again, once this is released, we'll be sending out communications. It's going to be released very soon in the very near future. And we have a micro training video that demonstrates all of the different things that you can utilize Databricks Assistant for, and how it can really help you with creating new code, as well as converting SAS code to a specific R or Python language syntax. So one other thing is that there is a pilot. We're working with another contractor who's piloting a SAS to Pi specific tool that might have the ability from an enterprise level to convert SAS code specifically to Python and to be able to convert thousands and thousands of lines of code with it. Again, there's really no tool out there that's going to do 100% one for one. This is SAS, this is Python. It's going to convert it exactly for you. You're going to need to make modifications. You're going to need to understand what it's doing, how it's doing it, why it's doing it, in order to make it adapt to our environment, to the system we're utilizing, and to make it available to work for you. But again, it's another tool that we might be able to bring into this community to be able to utilize and let others use, to at least get us walking into the right direction to convert our code. So now with that, I want to kind of just walk through a real quick demonstration of how I utilize ChatGPT to specifically convert this SAS code that I did, that I put together real quick, that pulls Part A inpatient-based claims data into SAS. It utilizes specific diagnosis codes that actually map directly back to this severe sepsis septic shock measure that's available out on QualityNet. And it creates flags for this measure. Say, hey, if any of these 25 diagnosis codes on this claim are in this list of codes, then I want to say this is a sepsis claim. And then it's just going to simply count. All of this, of course, is in SAS, which is very similar, and everyone probably sees this. Probably even has something similar to this in your everyday code. So how did I go about getting this to convert? Well, the first thing I did was I did it in chunks. All right. I have a macro that simply goes in and it loops through one at a time the claim diagnosis code, 25 of them, and it basically just creates me this list of diagnosis code variables. So I don't have to sit there and list out on 25 separate lines or 25 separate times. I want all these 25 diagnosis codes included in my output. I can now just call this simple macro variable called DX within my SQL select statement, and it's going to include all 25 diagnosis codes. So how do I do that in Python? Well, I asked ChatGPT. And I do want to preface this with ChatGPT. Absolutely, like anything else, there is no PHI and PII data allowed. You are not allowed to feed ChatGPT data. You are not allowed to feed it code that has an MBI value or a Hicken value or something with having to do with claims. You're not allowed to feed it anything when it comes to servers or host names or locations of that type of stuff, right? So it's very, very critical that what we utilize it for is specifically for code. Now, if you're going to include a database or schema and table, that's okay. That's no problem. You're not feeding it the data. It has no idea what that is mapping back to on the back end side of what servers and hosts and different things it's going to. But really, it's not a big deal if you're telling it, hey, this database and this table. It doesn't matter because it doesn't know. Very much no PHI, PII data, clearly. And no data being uploaded to it in general is what the absolute thing is that we cannot allow. Otherwise, it will be taken away. And taking ChatGPT away will be a very, very big hindrance to the community moving forward. So again, I want to show what I did just yesterday. Starting off with, how do I convert SAS code? So I literally typed in my macro that I created, and I said, I want you to convert this following SAS macro into Python. And it provided me this code snippet, and it explains to me what this is doing. It's generating a string similar to what the SAS macro is doing. And I can use this function to obtain the desired string called dx. Same exact thing here. My macro is dx, which lists all 25 diagnosis codes. So then I said, all right, that's cool, but I want you to add comments. So it then gave me the exact same code and it added comments. So what can I do? I copied it and I threw it into here. Now I've got code that basically does the exact same thing that this does, right? We've already seen what this does. It's simply producing a macro variable right here. And now I can simply run this. And as you can see, it produces printing the dx variable, and it's the exact same thing. So the next piece, I'm extracting claims data. As we can see, pulling from NCH Part A, inpatient skilled nursing facility header, pulling 3 months worth of claims, keeping only inpatient, only those that are final as of the time I'm pulling this, and I want only the first claim segment. What I'm doing is I'm bringing this all into a SAS data set that is going to be stored in the SAS work library called IP-based claims. I'm going to get this log out. I ran this already. So this ran, it took about a minute and provided me with the certain observations and certain number of columns. So I know for a fact that all this %select to data set is doing is sending this SQL query. Again, it's just SQL syntax. It's sending it to the Databricks SQL warehouse. It's executing it, and it's bringing the results back into a SAS data set, reading that data into the PDV and putting it out into a SAS data set. So now I know all I want to do is pass this SQL query and bring it back into a data frame. Here you can see I'm using Spark SQL. Again, this is an F string. And what this F string is doing is it is allowing me to pass variables. What do I mean by variables? I mean, I am now passing this dx variable that I created up here that was done at the exact same way on the SAS side, ampersand dx, calling a macro variable. This is the same thing. I've got squiggly brackets, and I'm calling this dx variable. So this executed, ran in 33 seconds compared to about a minute on the SAS side. I went ahead and said, all right, I want to know how many rows I'm getting. And you can see here I've got 2 fields within my data frame on top of the additional number of fields, which is 36. So that's 38 columns. And I've got, what is this? 2 million, a little over 2 million some rows. So let's map it back. I've got 38 columns and I've got 2040687 rows. So this provided the exact same observations, exact same columns, doing the exact same thing, except now I've got a Spark data frame within my notebook rather than a SAS data set within my SAS session. So now creating the list of diagnosis codes. How I'm doing it here is I just created a simple data set. Then I'm pulling each of the fields into a macro variable list. This is actually incredibly way simpler on the Python Databricks side than it is on the SAS side. What I can do is simply just create a variable, putting the codes in a list. This is the exact same thing that this is doing here. It's just a list of codes that I'm putting in a macro variable. This is just a list of codes that I'm putting into an actual variable. Now, if I did want to actually maybe got an Excel file, I want to import the Excel file into a data frame, and I want to extract codes out of the data frame to put them into a list. I don't have to hard code this. I can do that. That's no problem. In fact, I'm still hard coding them here just for this example instead of putting them into a CSV or Excel to import. I'm hard coding them into what's referred to as a dictionary here. And then I'm just simply setting that dictionary equal to a pandas data frame. I'm going to convert that pandas data frame to a Spark data frame. And then what you can see here, and again, I got this off of ChatGPT, asking it, let me find it. I'll come back to it. All right, I want to make sure I've got enough time to go through the rest of it. But basically, what is it doing? It's creating a SEP1 list here. It's empty, and it's going to take this data frame that I've got. It's going to go row by row and collect the value of code and append it to my list. I ran this less than a second, and now I've got a variable called SEP1, where it's just a list of diagnosis codes. All right, next, my data step. I have got an array statement where I'm listing out diagnosis codes 1 through 25 fields, and I'm basically looping through each one of those fields to determine, all right, does diagnosis code 1, is that value included in this list of sepsis codes? If it is, mark this as a 1. And then it's going to iterate. Diagnosis code 2, diagnosis code 3, diagnosis code 4, all the way to 25, and every single observation. So I asked T, you're going to, I'm going to show you here real quick. I want to make sure I save a little bit of time for some questions. It didn't work right away. It does eventually work, because here's what I said. Convert the following SAS code into Python. And here's the code that I just said. Data step, array statement, going to do loop, setting a flag. It gave me this. Not very pretty. It's giving me, I got to list out 25 separate instances of diagnosis code. I didn't like it. So I said, is there a way to iterate over the 25 diagnosis codes rather than listing them separately? I said, yeah, sure. Here you go. Here's how to do it. Provided me this. So what you'll find, I found running that is I ran into some errors. This was, yeah, let me find that. So I said, following PySpark code gave me the following error. Too many positional arguments. And it said, yeah, that's you're going to get that. Here's how you can correct it. So I plugged it in, ran it, an error. And so I said, yeah, that gave me this error. And it said, oh, see the issue, here's the corrected code. So I tried that, and it gave me another error again. And I said, no, that still gave me this error. So it corrected it again, provided it to me using this reduce function, ran that, and it worked perfectly. So again, it's not going to give you everything right away. It is going to be able to provide you further additions if it is running into errors. And so I ran that. It ran in 4 seconds. On the SAS side, it took about 12 seconds or so. And then now I wanted just to confirm. All right, now I want to roll this stuff up. I want to make sure I got this correct. It's giving me the exact same flags, counts, and distributions that I would expect it to see. Here's the SQL code. Here's what it produced on the output. And so again, I fed this into a GPT. I said, convert the following SAS code to PySpark, providing the SQL procedure. And it said, here you go. Here's how to do it. And then I said, well, this gave me a bit of an error. And it said, oh, yeah, it's expecting a number. So you've got this format string. And so then I wanted to be able to format output, include commas, like I'm doing in my code here with a format statement. And it provided me with this format number count thing, actually threw me an error. And I said, hey, this threw me an error. And then it said, all right, that's right. You need to format string it, this. And so After that, what I was able to do was type that in again. Did notice there was a small issue with the order and the arrange of the columns when it went to combine the two data frames. And so I just did a simple select statement on my end, which is, again, you're always going to need to be manually modifying a few things. But ultimately, here's what it produces. And so to be able to compare that, am I getting the same output that I'm expecting to be getting? The answer is yes. Total number of claims, unique number of beneficiaries by year and month, as well as across the 3 months, and how many did not have a SEP1 flag and how many did have a sepsis flag. And those counts are identical. So again, 3-4 seconds. I mean, all in all, it runs faster. This actually runs a little bit faster on this side because of the group buys, but all in all, it runs faster. It produces the exact same output. And I utilized ChatGPT. I also utilized Google in order to be able to identify knowing exactly what I needed to do on the SAS side, what the SAS code was doing, and taking segment by segment, chunk by chunk on how do I do this in Python? How do I do this in PySpark? Utilizing ChatGPT to help me understand, providing me information on specific things to do. Literally giving it SAS code and saying, convert this code to be PySpark. I was able to get this all done. I don't even know. It took me a couple of hours maybe, with the rest of my stuff to be able to get this done, ran and confirmed, okay, this is good to go. And now I can really put a better understanding of what is this doing. And notice that each time it produced code, it knew I wanted comments. The first time I asked it to include comments in the code, now it's including comments every single time it's providing and giving me code. Now I know exactly what it's doing. With that, there's only 5 minutes left, but I definitely want to give some time back to see if there's anything else that I can do.
Hey, Derek, before I take over sharing again, just in case you need your notebook for any of the questions, Aaron did go through and had been answering while you had been sharing.
Awesome.
So a lot of them have been answered already, but one we just got was, where did you save the data that you got?
So I've not saved this data yet. This is still ultimately in a data frame. Ultimately, the data frame with raw claims is in the sepsis flag is this IP base claims SEP1. What I can do with this data frame is I can write it back to the CDR into a database table, or I could export it out onto my S3 workbench as some kind of Parquet file, some kind of text delimited file. If I wanted to create and output this aggregation, I could, put it into an Excel file. It could, again, output it as a text file, CSV, to a database table, whatever you want to do. Ultimately, what you're going to find is that we do not want to try and save data within the workspace of Databricks. And when I say workspace, I mean stuff here. There's limitation on the size of a single file that can be stored within workspace. Data should be stored at the S3 workbench, just like you do with your SAS datasets, like you do with exporting CSV files or text files or Excel files out onto your SAS workbench. That SAS workbench is the same thing as what I'm referring to as an S3 workbench. Your compute cluster has direct access to be able to read files in from that workbench, as well as writing files out to that workbench. And again, depending on what your ultimate goal is, where you want to end up with this data, what you want to do with it, you can write it to a CDR database table and then maybe utilize QuickSight with some dashboards and visualizations there. If it's a report that you're looking to do, as DBA mentioned and Rebecca mentioned, there's ways to be able to export all of this stuff and write it out into an Excel file. You can even move templates, Excel templates, to be able to write to those templates and then bring them back to your S3 workbench, where you can have access through UFM, the former File Cloud MFT. Now it's Unified File Management. Again, this is going to be some stuff that we're going to talk about in office hours and present with use cases on how you can get data into onto your S3 workbench. Obviously, a lot of people are probably used to loading data on the SaaS side with SaaS Studio or something. You can do that with UFM, just like you could do it with File Cloud. And that's going to be accessible to you on your compute cluster with Databricks.
Hey, Derek, just a heads up, we are at time.
Perfect.
All right, so let me share my screen quickly so we can see the next session. Okay, so I know we had a few questions that did not get answered in our Zoom chat. All questions will be published on our Confluence space, and then eventually that will also be transferred over to Portal, but for now it's kept in past events in Confluence under DataCamp. The Q&A we'll be reaching out to presenters after DataCamp ends, getting them to write up any answers for questions that didn't get answered during our actual sessions. And then we will be delivering those on that public space. That way everyone can access them, even people who didn't get to attend the actual sessions, along with session recordings, and slide decks will be made there as well. So those resources are coming. It's going to take us a few days to turn them all around, but be on the lookout for those, and then we'll be sharing that out when they're available as well on Slack.